Good morning or good afternoon, everyone. Thank you, Ian, for offering me the opportunity to update you on 3 ESA projects, Sen2Agri Sen4CAP, which you might know already, and a new one, which is the Agricultural Virtual Lab. Let's start with Sen2Agri. This is a project, a system which you have heard already. So this was a this was a project during 4 years, 2014-2018. And during this project, we developed an open source system which is able to ingest automatically Sentinel-2 and Landsat 8 to deliver along the season 4 core GeoGlam products, which are cloud-free composites, biophysical indicators, cropland mask, and crop type map. The project is over now, but the system is still maintained and widely used by a diversity of stakeholders. So since the beginning, the system was downloaded more than 2,000 times. And I take the opportunity of this presentation to announce that a new version will be released this week, just to confirm that the system is really continuing, evolving, and being used. We developed and we put in place different tools to support the user community. There is a forum. We are organizing webinars every 2 months. We have been also organizing trainings, hands-on training, but also online trainings under request. And maybe something new, we see now that Sen2Agri is being uptaken by a service provider to offer easy solution for the stakeholders. And a last example is the click and go solution, which will be available on the Amazon Web Service and which is supported by the Geo Knowledge Hub. So I think that Ian will tell you more about this initiative in a separate slide. But this is just to show that, so Sen2Agri is a tool that allows any stakeholders, any country, any users to run its agricultural monitoring easily. And this solution allows really accessing the service on the cloud and just running it without taking care of the IT constraint. So this was for Sen2Agri, and based on building on Sen2Agri, we started a new project which is named Sen4CAP, Sentinels for the Common Agricultural Policy. This project is still ongoing, but we are really in the last phase of it. So the objective of the project was to provide evidence that information derived from Sentinel Time-Series could support the reform of the CAP. And the project aimed at providing algorithms, workflows, best practices to use this Sentinel data in a relevant manner for monitoring agriculture, supporting the CAP. And so the way we handled this objective is to develop a system, and within this system to build a very large database of metrics or markers at the parcel level, which are relevant for the crop mapping and the monitoring of agricultural practices. And these metrics or markers are derived along the season from Sentinel-1, Sentinel-2, and they are populating this database along the season. So the project was organized in 3 main phases. First R&D, then the demonstration and validation, and we are now in the last year, which is about the user uptake and the last evolution of the system. So this is, as I presented you just before, the way the Sen4CAP system is organized. So the first and main step is to derive markers from Sentinel-1, Sentinel-2, and to organize these markers in a database which is growing along the season. So these markers within the Sen4CAP project have been used through a selection of use cases. So we selected use cases with the paying agencies in Europe, and we developed 4 kinds of products to do so. So crop type mapping, growing vegetation indicators, grassland mowing detection, and agricultural practices monitoring. Of course, the database of markers can be useful for many other applications and to derive many other products. And so this is really the objective of these markers. This is to open the possibility in terms of agricultural monitoring. But within Sen4CAP, we really focused on these products and these use cases. So during the project, we demonstrated these markers and these products during 3 successive years, 2018, 19, and 20. And you can see here that where we have been working. So we have been working in 7 countries in Europe. At the beginning, during the first year, the production was done at the end of the season. But from 2019, we started running the monitoring in near real time. So really along the season with the paying agencies, as soon as they provided us the declarations of the farmers, we were monitoring the parcels, and we were monitoring if the declarations of the farmers were in agreement with the output of the time series analysis. This is an example of crop type map that we got in Czech Republic this year. So national crop type map with more than 60 crop types in the legend. So this crop type mapping has been done by analyzing the full time series from March to end of August, and by calculating markers from Sentinel-1 and Sentinel-2 every week or every 10 days. So this is a very huge work. And you can see that the accuracy is really quite good, quite high. As expected, the accuracy is evolving over time. So we got the highest accuracy at the end of the season in August here. But still from May, June, we have very interesting accuracy that can already be used by the paying agency to do the monitoring. And so this product is used to here compare the prediction of the remote sensing data, so the map, with the declarations of the farmer to see if this is in agreement or not. A second type of product is related to the detection of the grassland mowing. And so here, the parcels which are declared as permanent grassland by the farmer are monitored. And for these parcels, we are looking at the mowing events. So in the European regulation, if you declare permanent grasslands, you are not allowed to mow your grassland when you want. There are some mandatory periods, and this is what we monitor if we detect mowings within this period and not before and not after. And so the output of this product is that for each parcel, you get the number of mowings that have been detected, a confidence level, and also the date. The third kind of product is related to the agricultural practices monitoring. And again, we are working with Sentinel-1, Sentinel-2. Here in green, you see the NDVI, and in black and red, you get the currents and the backscatter derived from Sentinel-1. And we are analyzing the markers week after week to detect first the harvest of the main crop. This is the blue line that is displayed here. And after the harvest, the farmer has the possibility to declare a catch crop or a nitrogen fixing crop or fallow land to get an additional subsidy. And the monitoring consists in checking if this crop is in place during the mandatory period and is not harvested before the end of the mandatory period, which is the gray color in the graph. So this is another example. So as I mentioned before, the Sen4CAP system is also providing biophysical indicators. There is a new processor which is under development and related to the detection of the tillage. And of course, using the database of the markers, any application can be developed and are being developed already outside of the project by other partners, for instance, related to agroecological indicators. So this is an overview of the Sen4CAP toolbox with Sentinel-1, Sentinel-2. You get the possibility to do the pre-processing or not. and these Sentinel-1, Sentinel-2 populate a marker database which are used to generate the different products. Like in Sen2Agri, we have put in place varying tools to support the user community. So forum, hands-on training, webinars, online training, question and answer on the chat. We also granted the access to virtual machine on the cloud to some countries to test the system. And the Sen4CAP is now implemented on a cloud, and the country can pay to get the system already installed and ready to be run. So this is very ongoing. The user uptake is really ongoing, and this is on what we focus during the last months of the project. My last slide will be about a new ESA project, which is starting just now. So the Agricultural Virtual Lab, AVL, and which will last during 3 years. So this lab aims at being a collaborative platform for the agriculture applications with remote sensing. And so this project addresses new or current challenges related to the increasing volumes and variety of data and the need for more cooperation. And so what the AVL will provide to the users? First, it should provide an easy access to a large variety of data sets useful in the agricultural context, meaning that the users will get an easy connection to many data sources, EO data, but also in situ data, auxiliary data set, etc. So we are in the process of defining the list of these very useful data set, and then with this data set, there will be all the functionalities to visualize, process these data into the results. So these platforms aims at really fostering the cooperation between the scientists, so between scientists from the same domain, but also scientists from different domains. And so we will really insist on that. And so we would like here to make a clear link with the GCAM community. So GCAM will be one of the champion user of this agricultural virtual lab. And we would like really to reach the same kind of success GCAM had in terms of collaborative approach. We would like really to encourage this approach here in AVL. So sharing in situ data, sharing algorithms, sharing results, and discussing the results between the different scientists. AVL will be a place where Sen2Agri and Sen4CAP will be maintained. And so this is a very important point. So the projects, Sen2Agri project and Sen4CAP projects are now over, but the system will be maintained within the AVL. And within these two system and the next one, so the Sen4Stat will be also here, and the Sen-ET, so Sentinels for evapotranspiration, will also be part of the system which will be maintained. So we think that these systems are providing building blocks for research in agriculture monitoring, and so they already have their place within this lab. So the project will last 3 years. And the development of the AVL will be step by step. We will first start with main use case implemented by champion users, and then we will get a phase with early adopters, young scientists who want to test the lab, and then the lab will be open to the wider community during the last year. That's it for me. I'm open to any question, of course. Thank you very much.